I had the pleasure of hanging out with the engineers that worked on that, and I'll tell you, there's more in that car than you can imagine in terms of what they're experimenting with. It was really exciting, and it was amazing to see the enthusiasm of the engineering team for what they were doing. You know, and it's also clear that as automation changes what we work on, it also changes how we work. So what do we need to change in order to prosper? Now, one company that has been thinking about this is Airbus. You might recall that 4 years ago, they used generative design to make a partition that was half the weight of the one it was designed to replace. This potentially saves 500,000 tons of CO2 every year. And from this important interior component, Airbus has moved on to optimizing critical exterior components. And they've started with the vertical tail. Everybody knows how important the tail is. They optimized its leading edge to be as stiff as possible and to weigh as little as possible. And because the vertical tail is critical to how a plane flies, they also designed it to be impact resistant. And now they are looking at what they've learned on this and figuring out how to apply it to the wing. All of this grew out of the work Airbus and Autodesk did 4 years ago. And today, we are working together to figure out how automation could help Airbus with a much bigger challenge. From their early work on structural optimization, they've shifted their focus to systems optimization, from parts like these to the processes that go into making them in factories like this one, where the A350's wings are assembled. Production of the wings involves sophisticated process, like carbon fiber layout. But the assembly line is a different matter. It involves a lot of human labor, drilling, cleaning, bolting, riveting, sealing, and all these different tasks require different tools. Going back and forth between the wing and the tool trays, the carts and the storage racks, involves a lot of walking. And while this walking might feel like work, it really is not work at all. It's simply activity. So we helped Airbus see how one bay could be configured for multiple wing types. They used generative design to explore how tools, locations, and configurations could be optimized for this process, as well as all the processes for all the variations of the wings from the different generations of the A350. We managed to reduce the distance of the key travel paths while also minimizing congestion and bottlenecks. Now, the line workers are absolutely getting in their daily steps, but they're also spending more time assembling the wings. It's a more productive factory and a more configurable factory. But this was just a proof of concept for something much bigger and much better. Airbus is now using generative design to optimize an entirely new factory for installing engines. It will open on its campus in Hamburg, Germany, just next year. And they embarked on this complex challenge for one very simple reason. The most favorable site on their campus is triangular, and the plot's smaller than Airbus would like. These are not ideal constraints, but Airbus knew that this shouldn't constrain their thinking. So they explored two paths. One path examined what a bigger building with a triangular footprint might look like, and the other path explored how the same factory might be optimized to fit into a smaller rectangular footprint. Whichever path they eventually choose, Airbus knows that the factory's form should follow its function. So they identified 10 different sets of variables to optimize for. Variables that covered the social, the environmental, the financial, and operational aspects of its design. The social aspects of the factory were absolutely a key consideration, as Airbus wanted the best conditions possible for its workers. And like so many of you, they wanted a building with the best possible environmental certification. But the factory needs to be affordable as well as sustainable. So Airbus considered the major financial drivers, the number of unique structural members, the length of these members, and the building's overall footprint. Cost matters to all of us, but what's really critical to Airbus was the way the factory operated. So they looked at the operational drivers, the different flow paths of the factory. The green lines you see represent the logistics flows, the loading and unloading and prepping of them and inspecting them. The blue lines represent jacking, jigging, and the many parts that need to be assembled. The red lines are the parts being moved through the different paint booths. We helped Airbus look at all the different flows of people and parts between these three key areas. Airbus was able to evaluate hundreds of options, and from these, Airbus chose several designs that looked promising. And then the team narrowed it down to these two. Both have better flow scores than the existing standards. So either factory functions more efficiently. The engines are installed more quickly, the logistic flows are more efficient, and so are the workers, because they take fewer steps each day. Overall, this one scored 40% better than the baseline. This one has a smaller footprint, which means that it fits squarely on the constrained site. And both options are less costly. So now they just need to choose the one that suits them best. To build a factory that creates more prosperity for the company and better conditions for its workers. It's a space where everyone can prosper.